The question number 26, a nucleus at rest splits into two nuclear parts having the radii in the ratio 1:2. Their velocities are in the ratio. So 1 is decaying into 2, so 1 goes to 2. In this case, we know that momentum should be conserved. So momentum of 1 plus momentum of 2, conservation, it should be 0. So momentum 1 should be equal to minus momentum of 2. The mass of 1 and the velocity of 1 is equal to mass of 2, velocity of 2. And you know, these are spherical in shape and mass is proportional to volume, and that is proportional to radius q. And if the radius, if one has mass of m, then the second will have the mass of 8 times. So mass m into v1 is equal to 8m into v2. Therefore, the velocity is v1 by v2 is equal to what? 8 by 1. So the correct option is the fourth one, 8:1. The question number 27 is, to produce an electron-positron pair, the minimum energy of gamma radiation photon must be. So you see that in pair production, when gamma radiations are generating two particles, one is the electron and second is positron, the energy of the electron is equal to m naught into c square, and this is equal to 9.1 into 10 is power minus 31 into c 3 into 10 is power 8 square. And if you want to change it to electron volt, so we divide it 1.6 10 is power minus 19, and this value come to be 0.51 mega electron volt. So that means if this electron exists, then it has energy of 0.51, and the second also have the energy of 0.51. So the total energy will be 0.51 plus 0.51, and that is equal to 1.02 mega electron volt. So gamma rays should have energy at least 1.02 because these particles are formed. So the correct option is 1.02 mega electron volt. The question number 28 is, a potential barrier of 0.3 volt exists across a p-n junction and the width of the depletion layer is 1 micrometer. An electron approaches this junction from the n side with velocity this one. The speed of the electron entering the p side. Now, dear student, this is n side and this is p side. And the potential, the barrier is 0.3 volt. And you know, if the potential barrier is this one, here is positive ions and on this side is negative ions. So the electric field is in this direction. And how much is the electric field? The electric field is equal to potential divided by the thickness. And thickness is 1 micrometer. Now, as this charged particle enter into this one with certain speed, it will experience the force in opposite direction because of its negative nature. So as it reaches here, it will be deaccelerated because of negative the force. Now the formula for constant acceleration v square is u square plus 2as, and the final velocity is u. The initial velocity is given 5 into 10 is power 5 square plus 2, and a is equal to minus EE divided by m into the distance, and distance is d given to you, and E we can fill v by d. So v square is equal to 5 into 10 is power 5 square minus 2 into 1.6 10 is power minus 19 divided by mass 9.1 10 is power minus 31, and the electric field is v by d, and v potential difference is given 0.3 and d cancel with d. And to solve this equation, we get the value of v equal to 3.8 10 is power 5 meter per second. Therefore, the correct option is the second answer. Question number 29. In the given circuit, silicon diode and germanium diode conduct at 0.7 volt and 0.3 volt respectively. The value of V naught and current I are. Now this is circuit given with battery voltage plus 12, and this will be at zero potential because they're earth. Now what happens? Out of germanium and silicon, the germanium has the breakdown of 0.3, the knee voltage. So at 0.3 volt, the germanium start conducting. So current start flowing in this circuit, and the circuit is completed. If you take the KVL by Kirchhoff voltage law, if 0.3 volt is potential here and this is 12 volt, therefore potential drop across this resistance will be equal to 12 minus 0.3, that is equal to 11.7 volt. If it is at zero potential, so V0 will be equal to 11.7 volt. So V0 is 11.7 volt. Now you want to find the current. If the current I is in this circuit, the same current is flowing from here, then by Ohm's law, the potential difference 11.7 is equal to I multiplied by the resistance, which is 5 ohm. Therefore, the current I will be equal to 11.7 divided by 5, and you solve, this become 2.34 ampere. So you have the voltage this and the current in this one, and look at the option. The option number 3 is 11.7 and 2.3 ampere. So correct answer is option number 3. Question number 30. In a full wave rectifier, the circuit operating from 50 Hz AC means the ripple frequency. Now dear students, if input is like this one, then you know that in output you get both the halves, and this is called the ripple, and the frequency of the ripple is double to the input. If it is 50 Hz, this will become 100 Hz. So the correct option is the fourth one.